So the question is contains duplicates. As the name suggests, we are given an array. Let's say the array is 1, 2, 3, 1. So the question says contains duplicate. That means this array has duplicate or not. As you can see, 1, 1, so it's a duplicate. So we return true. Now let's take another example. Simply the counter example, 1, 2, 3, 4. Every element is distinct, so we return false, as there is no duplicate here. Okay. So how to solve it? Now, as a human, when we see this array, we don't realize it, but what we do is we check pairs. We see that we are checking pairs very fast. Our brains are working fast. Then we see this pair has both elements equal. Now same for this, we check all the pairs like 1, 2, 1, 3, 1, 4, 2, 1, 2, 3, 2, 4. This is same actually. And then 3, 1, 3, 2, 3, 4, 4, 1, 4, 2, 4, 3. Then we see that there is no pair exists out of these 12 pairs that has both elements the same. So we conclude that this is false. Now how a computer does it is by using two for loops, and this is a brute force solution. So we take an I and we take an j. Like I is it here, so j goes from here, all the pairs. Then again I is here, so j, j, j. Then I, j, j, j. Then I, j, j, j. So the code goes like I 0 to n, j 0 to n. If I not equal to j, if I equal to j, then continue. So this is the brute force. The time complexity is O(n) square and the space is O of 1. So we need to reduce this. O(n) square is not that good. So what we are going to do is our next solution is the better one. It will take same space, which is O1, but the time will be decreased. So let's say the array is 1, 4, 9, 1, 2, 10. Now we can see that these are duplicates. So what we want is, we know that if we sort an array 1, 1, 2, 4, 9, 10, then every duplicate so now we sorted the array, then we can see, let's assume this 4 was actually a 2. Okay, so now 2 will be here. So what we observe is, when we sort the array, every duplicate will be neighbor of each other. If let's say there was another 1, then there will be a 1 here too. So all duplicates will be together. So what we can do is, once we sort the array, then we can just loop from the starting, and then we can see that if we found any two elements which are adjacent and also equal, that means that's a duplicate. So we just return true and we stop there. So this will take, sorting will take O of n log n, because that is the best time for sorting using merge sort, and then one loop through the array, which is O(n). We will just take this one because this is bigger, so we ignore this. So this is O on time and O of 1 space. Now what if we want to do it in linear time? O of n. So there's another solution for that. Let's observe what happens when we solve this type of question. 1, 2, 3, 1, 4, 5, 7, 8. This is the array. Okay. So what we want, by the time we reach this one, we need to remember that we have seen a 1 before. How will we do that? So the first solution is using a hash map. What we are going to do is do one loop through all the arrays, and for each element we will just use a map and store the frequency of this element. So 1 came once, so we store this frequency, then 2, then 3, then every element we store the frequency. So by the end we have every number's frequency is 1, but the 1 frequency will be 2 because this appears 2 times. So now we have the map. Now we do another traversal of the map, and we see if any value in the map has a frequency greater than 1, that means that is a duplicate, and then we return true. And if we cannot find any element which has frequency 2 or 3 or 4, anything greater than 1, then we can conclude that this array has no duplicates at all. Okay, but what's the problem with this solution? Right now we have 1, 2, 3, 4, 5, 6, 7, 8 elements, but let's say if this array was very big, 10⁵ elements. If we use this frequency map solution, then what we are going to do is we will use the whole array till the end, every element, and then we will store every element's frequency in the map, and then we will check in the map. So this is, we can sense that this is not optimal. Technically, in time complexity and space complexity of the worst case, this is optimal, but we can do further optimization on this. How can we do that? So we saw that if we can just stop here when we found the first duplicate, then we don't need to calculate extra things that we do not need later. So we will use another way of hashing, which is HashSet. Set, as we know, is a data structure that stores an element, and basically it's a map that stores frequency 1. It does not store frequency more than 1, it just tells us if it has occurred once before or not. It doesn't care if it has occurred twice or thrice, it just knows that it has occurred once or not. So what we're going to do is we will add elements in the set. 1 is it has not occurred before, okay. Now 2, 3. Now when we reach this one, we saw that we have already a 1, set knows that. So we check that for every element we check if the set contains it, that means it's a duplicate, so we return true. If it does not contain it, then we add it. So let's say if there one was here, let's assume, so it will add 4, 5, 7, 8, and then in the end it will see that 1 is already a map, so it will return it will return true as we found a duplicate. So this solution also is O n time and O n space, but technically if we go deeper in the logic, then it is a little bit better than the HashMap solution. So these were the 4 ways to solve the question. Thanks for watching. I will try to upload at least one video daily, and we will cover every question of the NeetCode 150 list.